Hi student, welcome back to class, and of course this is Learn Chemistry with Emerald, and then we have started with the gas laws and their equations. In the other video I talked about Boyle's law, Charles law, pressure law, general gas law, and then ideal gas equation. Okay, these laws are important. Again, we can look at another law, which is Avogadro's law. Avogadro's law states that equal volume of all the gases at the same temperature and pressure are the same with the number of molecules. That is, the volume of all the gases, V, is directly proportional to the number of molecules. Now we are in Avogadro's now. And then at pressure, temperature, constant. So this is the interpretation of Avogadro's law. The volume is directly proportional to the number of moles at a constant. So this is Avogadro's law. Avogadro's law. Now this is Avogadro's law. Okay. Now another law is Gay-Lussac. The major difference between Avogadro's and Gay-Lussac is that Avogadro's talk about number of moles, while Gay-Lussac talk about volumes. Gay-Lussac talk about volumes. Now Gay-Lussac said when gases react, they do so in volumes which bear simple ratio to one another and to the volume of the product if gaseous, provided temperature and pressure remains constant. That means when volume A reacts with volume B, they now do so in volumes. So let's say volume A and volume B react, then they do so in such a way that when they give back to C, all of them are in simple ratio. Let's say X ratio Y ratio Z. So this X, Y, Z, they are what? Simple ratio. Note that if gaseous, that means all of them must be gases. So Gay-Lussac talk about gases purely, and then of course he is saying that when they react, all of them, both the reactant and the product, they must be gases, and then they are in simple ratio. Their volumes are in simple ratio to one another. So this is the interpretation of Gay-Lussac's law. Gay-Lussac's law, and then the final law we look at is Graham's law of diffusion. Graham's law of diffusion says that the rate of diffusion or effusion of a gas is inversely proportional to the square root of its vapor density. Now this is what it means. The rate of diffusion R is inversely proportional to square root of what? Vapor density. Now of course we are going to take it further by saying that R is equal to K root D, and then R over root D is equal to K. So this is Graham's law. Graham's law. Now we are going to move on with this law. It does not finish from here. Now let me now express how this law is going to be. Now let me express how this law is going to be for Graham's law. Now let's break it down a bit so you can understand. Now you will recall that we can say from this equation R1 over root D, or let's say R1 over R2 is equal to root D2 over D1. I hope you from here, if I break this one down here now, I will say since they are inversely proportional, now of course this one and this one. So we have here, call this one equation 1. Call it equation 1. Now recall that the rate of density is 2 times vapor density. Density is 2 relative molecular mass rather is 2 times vapor density. That means 2 times Vd is equal to relative molecular mass, RMM. That means they are directly proportional to one another. That means wherever we use vapor density, we can use relative molecular mass. Therefore we can still say R1 over R2 is equal to root M2 over what? M1, where M is now the molecular mass. Okay, then we can proceed further by saying that since rate is inversely proportional to time, then therefore we can say R1 we can say R1 over R2 is equal to T2 over T1, abi? Then if you have if you have this, we can say, let's call this one equation 2. We can say R1 R2 is equal to T2 T1, then equals to root D2 over D1 equals to root M2 over M1. Now this is a complete set of the equation we are under Graham's law. So each of them, let me call this one 3. Each of them can be given. They can give you this and this. They can give you this and this together. Now they can give you time and this. They can give you this and this, as the case may be. The final equation under this, the final equation under Graham's law, is that your rate of diffusion R is equal to volume in centimeter cube, volume in centimeter cube over time in seconds. Volume in centimeter cube over time in seconds. Call this one equation 4. Call it equation 4. So for Graham's law of diffusion, you have this, you have this, you have this, which is a comprehensive from the first two, and then you have this. So these are equations that we use in this Avogadro, Gay-Lussac, and Graham's law of diffusion. Of course, from now we are going to start working on solving questions and that. Thank you, and God bless you for listening.